Okay, so if I have 64x to the 300 times y to the 600, all raised to the 1/3. What do you want to do first? What's your instinct? Distribute. You want to put it all in a cube root. Okay, you can do that. When you said distribute, I think you're thinking the right thing. It's just not called distributing in this case. Yeah, but you could raise each of those three factors to the 1/3. If those three things were added together, you can't raise each of them to the 1/3. It only works with multiplication. Okay, so there's more than one good approach, but the 1/3 power, 1 is the exponent, 3 is the root. So we could write this whole thing as 64x to the 300, y to the 600, all cube rooted. Okay, the 1/3 power is the same as the cube root. And then you can take the cube root of each piece separately, which is kind of like distributing. So this is the cube root of 64 times the cube root of x to the 300 times the cube root of y to the 600, and then cube root of 64. So a number that when you multiply it times itself 3 times, you get 64. 4. 4 times 4 is 16, and 16 times 4 is 64. So this is 4. All right, so the cube root of x to the 300. What do you cube to get x to the 300? Yeah, x to the 100. Yep. Because when you raise a power to a power, you multiply the exponents. So x to the 100 cubed would be, you'd multiply the 100 times the 3 and you'd get the 300. All right, and then the cube root of y to the 600, y to the 200. Because 200 times 3 would give you the 600. All right. How's that? Any questions on that? Okay. 8 to the negative 2/3. So we're dealing with two things here, negative exponent and a fractional exponent. So let's deal with one of the two things first. We'll deal with the negative. How do you deal with a negative exponent? Flip it. So by flip it, I don't mean flip the exponent. I mean take the whole thing and put it in the denominator. So the exponent stays 2/3, it just is now positive. So instead of 8 to the negative 2/3, we get 1 over 8 to the positive 2/3. All right, so the 2/3 exponent, 2 is the power and 3 is the root, right? Because roots belong in the cellar. Anybody heard that before? Okay, so the 3 is in the cellar, it's in the bottom of the fraction, so it's a root. All right, so this is 1 over, and you can do the root and the power in either order. So I kind of like to do the cube root first for this one because I happen to know the cube root of 8 off the top of my head is 2. So I can do all this in my head. So this is 1 over 2 squared, which is 1/4. Maybe I should have written down that intermediate step. 1 over 2 squared, 1/4. Okay, so that reminds us how to deal with fractional exponents and negative exponents. All right, some roots here. 3 root 12 minus root 27. What do I need to be able to actually do this subtraction?
You need to break down this one.
I need to break down those roots as much as I can and hope. What am I hoping for when I break them down? That the roots will match. Yeah, because then they'll be like terms and I can do the subtraction. Okay, so 3 root 12. This becomes 3 times the square root of 12. I want to rewrite it as a product of a perfect square times something. 4 times 3, yeah, because 4 is a perfect square and it goes into 12. And then 27, I want to rewrite, yeah, 9 and 3. All right, so then the square root of 4, I can simplify to what? 2. So this becomes 3 times 2 times the square root of 3, because the square root of 4 became a 2. Right, and then 9 times 3, the square root of 9 gets simplified to a 3. So this is now 6 root 3 minus 3 root 3, which is 3 root 3. Okay, so that's how we simplify radicals. And when you add and subtract radicals, you treat them like terms, like as if they were an x. Okay, if I want to factor 5x cubed minus 45x. Any ideas?
Take out an x.
I could take out an x, and I could take out a 5. Yeah. So 5x goes into both of these things. So it's kind of like I'm reverse distributing, right? So if I was going to distribute the 5x to this set of parentheses, what would have to go in this first spot to get 5x cubed? X squared. Yeah. Because x times x squared will give me my x cubed, and I get the 5 outside already. Okay. Yep, minus 9, because that will give me my 45x when I distribute. But what's true about x squared minus 9? It's the difference of squares, difference of perfect squares. So it factors further. So we can have 5x. Anyone remember how to factor a difference of squares?
3x minus 3.
Yeah. X plus 3, x minus 3. Very good. Okay, if I want to reduce a rational expression, a fraction that has variables in it, to lowest terms, I should factor as much as I can and cancel if I can. So x squared plus 3x minus 10, does that factor?
Yeah.
I hope so, otherwise we can't finish the problem. X plus 5 and x minus 2. Good. Yeah. So a lot of factoring is trial and error. A lot of people have learned it using this box method, right? Where you know you need an x squared here and a negative 10 here. And so you go, okay, I need to have an x and an x to make an x squared. And then you need to put numbers here so that when you multiply them together, you get negative 10. And when you add these two boxes together, you get 3. If you haven't heard of it and you don't want to learn something new, just ignore me. That's fine. If you have your own method. So I would have to put a 5 here and a 2 here to make a 10, but it has to be a negative 10, which means one of them has to be negative. But I want the sum of these two boxes to be positive 3, so this one has to be positive and that one has to be negative. So that's just one little way to do it. And so this becomes 5x and this becomes negative 2x, and you see they add up to 3x. So it's just one way that people have learned how to do it. I just learned how to do it by writing down the parentheses and guess and check. Do whatever you like. All right, let's look at the denominator. X squared plus 2x minus 8. You've got to have an x in the first spot so that when you're distributing, you get x squared. I need my last two numbers to multiply to negative 8 and add to 2. Plus 4 and minus 2, yeah, because now the positive 4 and the negative 2 multiply to negative 8. But when you do the outer and the inner terms, when you're doing the distributing or the foiling, you get the positive 2x. So do I have any factors in common on the top and the bottom here? Yep, so I factor them, I cancel them, and I'm just left with x plus 5 over x plus 4. Now, here's a really common mistake. Can I do this? No. You can only cancel things if they're connected by multiplication, right? These things are connected by addition, the x plus 5 and the x plus 4, so you can't cancel the x's. All right, last one that we'll do together. I want to add these two rational expressions, 3x over x plus 2 plus x over x minus 2. What do you need to be able to add two fractions? a common denominator. What could my common denominator be? X plus 2 times x minus 2. Yeah, sort of like the easiest way to get a common denominator is to just multiply the two denominators together. So if I multiply both sides, well, let's 3x over x plus 2 plus x over x minus 2. So my common denominator is going to be x plus 2 times x minus 2. So I'm going to multiply the top and bottom of this fraction by x minus 2 over x minus 2, and the top and bottom of this fraction by x plus 2 over x plus 2. Yeah, I don't know what's happening there. All right, so now I have a common denominator, x squared minus 4. That's what you get when you multiply those things together. So my first fraction, 3x times x minus 2, is going to be 3x squared minus 6x over x squared minus 4 plus my second fraction, the denominator is going to be x squared minus 4. That's what you get when you multiply those two things together. And x times x plus 2, you got to distribute it. So you get x squared plus 2x. All right, so the whole point of getting the common denominators is so that I can add the two fractions together, right? And once you have a common denominator, the way you add the fractions is you just add the numerators, and the denominator stays the same. So this is going to be an x squared minus 4 on the bottom, and then I combine like terms. I've got a 3x squared and an x squared. That makes 4x squareds. Negative 6x plus 2x is negative 4x. Yep, good enough.